All right, I decided to throw in another checkpoint here on domain and range and a little bit on functions. Um, we're going to do equations here and we're going to do graphs. And just give me the domain and range. And then the last question here is which one of these are functions, or which of these are functions. For these, you just want to, the domain is what makes sense to put in for x. What could I input for x that makes sense? Doesn't mean like give me one answer, just it's a variety of answers. So is it all numbers? Is it whole numbers? Is it integers? That kind of thing. The first one is what could I plug in for x? Well, this is just in a line. So like if I make an xy table, you could plug in anything you want for x. So here it's all numbers. And I do say include an x or y in your answer. I just want to make sure you just put x equals something in this one. So here I'd say x equals all numbers. If you prefer to use the inequalities, you could do something like this. You could just say x is greater than negative infinity and less than infinity. That covers all numbers. But this is probably the easiest one right here. And then range, once I plug in those values for x, any number, what do I get out as a result? That's my range. Well, in the XY table, you get all possible answers here, so same thing. So y equals all numbers. And again, I could do it in this format and put a y right there. Number two is square roots now. I cannot input something that would give me a negative under the square root, because I can't take the square root of a negative number. So what I usually do is just make this 0, so I know where to start. So if I let x be 7, 7 minus 7 is 0, I can take the square root of 0, so that's fine. But if I went smaller, like 6, 6 minus 7 is negative, I can't take the square root of that negative number. So my minimum value is 7. So my domain is all numbers greater than or equal to that 7. And if I prefer, I could write it in this form. I don't have space to put this right. Like 7 is my smallest value, and it goes out to infinity. I could do it in this form as well. Okay. Range, once I plug in those values, so 7, 8, 9, 10, and all the decimals, of course, in between, what do I get? Well, if I plug in 7, I get 0. If I plug in 8, 9, 10, bigger numbers, I get bigger than 7, bigger than 0. So just positive numbers. So y is greater than or equal to 0. You could say y equals all positive numbers and 0, I guess, but this is just the easiest way to do it that way. Number 3, what can I input here for x? Doesn't matter. It doesn't matter if I get positive, negative, or whatever inside of here. So all numbers. So x is all numbers. And once I plug in any number, what do I get out as a result? Well, the smallest value I get is 0. Like if x was 4, 4 minus 4 is 0. Absolute value of 0 is 0. If I go bigger than that, I get these couple negative numbers here. Like let's say I go 1. I get negative 3, but then it's the absolute value of that, and it's positive 3, or that kind of thing. So I get all positive numbers. So same thing like over here. My result, my output is 0 and bigger. So y is greater than or equal to 0 in this particular case. If there's a negative out front, it's going to change things. And some of your checkpoints will have the negatives out front, so be careful with those. And then here, I got a little tougher one here with a negative out front there. It just changes what I do after I square something. So I get rid of that mess. Again, I can input anything. So x is all numbers, because I don't have to worry about a square root or dividing by 0. Possibly I have something like x plus 3 over x. So here x could be anything except it can't be 0, because again, I don't want to divide by 0, that kind of stuff. And my output, once I input anything, I'll square it, okay, and then I'll subtract 9 from it. Well, this is a pretty tricky one. If you might want to try a little XY table to find a pattern here, if you get any confusing ones like this. But if I plug in, let's say 0, 0 squared is 0, the opposite of 0 is 0, 0 minus 9 is negative 9. So maybe I'll just do this, 0, negative 9. Let's go larger. Let's go like 1. 1 squared is 1. Negative 1, the negative in front. So negative 1 minus 9 is negative 10. Well, let's do negative 1. Well, that's going to give me the same answer, because negative 1 squared is still 1. Then I put the negative on it, and I get the negative 1 minus 9. Gives me the same negative 10. So if I have negative 1, I get negative 10. If I go 2, 2 squared is 4. Then I have a negative 4 minus 9. That's a negative 13. So these numbers are getting further and further negative. If I put in a negative 2, same thing happens. So my largest number is negative 9. Everything is going to get smaller and smaller and smaller as an output, these numbers. So if I say, I'll have to write y is less than or equal to the negative 9. I could write it that way. That's probably what you'll do. Let's get a bigger eraser here. But you could also say negative infinity is less than y, which is less than or equal to the negative 9. I think it's just easier to do that. You could say all numbers y equals all numbers less than or equal to 9. You could do something like that. As long as you use the letter y somewhere, you won't lose any points. All right. Then let's go on to the graphs. Now, I think these are actually easier than the equations because I just visualize a box going around these things. Like this is a box cornered inside here. Boom. And that's my domain and my range, just inside that box. Gets a little trickier with the arrows that go on forever. Let's walk through these quick. So here, x's, my biggest x is right here. It goes up to 1, 2, 3. It goes up to 3. Not that we can see it or anything. So x is less than or equal to the 3. And then, because it goes left this way forever. And then y value, the highest point it reaches is this value right here. So y is less than or equal to a positive 1. Over here, the highest, I'm sorry, let's go x. Left and right, the smallest x I have is right here. So negative 1, 2, 3. So negative 3 is the smallest. Okay. And it includes the negative 3, so I'll do that. And its largest point is right here. So it looks like 1, 2, 3.5. So I'll just estimate that at 3.5. In other words, x is between, these are all x's here, between the negative 3 and the positive 3.5. And then y's go from this low point, which is 1, 2, 3, 4, 5, 6, negative 6 it looks like, up to the highest point. Now don't pick this point here. Go up to the highest point of any point on the graph. And that looks like it's a 4. Look at that a little better. 1, 2, 3, 4. Yeah, it looks like it's 4. Okay. Now over here, the way this graph looks kind of silly. It looks like up here, if I have a dotted line on any of your checkpoints, assume that it's not going to cross the dotted line. This is called an asymptote. And the line, this approaches it and approaches it, approaches it, goes closer and closer, but never reaches it. On the other hand, when it's down like this, I want you to think of it like a parabola type situation where it kind of goes out and down forever. It does not level off. Like this doesn't level off either, but it approaches a value. This one will not approach a value. It doesn't like approach negative 10 here. I want you to think of this always as going on forever into the negative like that. Okay? So I'll have to explain that in class when we go through these. But so the domain, the smallest value is right here. So x is greater than, because it goes to the right, negative 1. And it goes on forever to the right. For the y's, the largest number is going to be almost 1. So it's going to be, so like, it's bigger than the, I'm sorry, positive. I don't know why I wrote negative 1. Ooh, big eraser. 1. So 1 is this, oh, why am I doing that? It's the other way around. The largest value is 1. So y is going to be less than 1, and it's going to go down to infinity. So it's greater than negative infinity. A little confusion there on my part, sorry. Okay. Now you don't have to worry about this. You could just write y is less than 1, and that's fine, because it goes down, as far as I'm concerned, it goes down forever. All right, and which of these are functions? For all these, people say just do the vertical line test on these, and that's fine. But I still need you to understand, for any input, there's only a single output. This one has 2 outputs, so that's not a function. For an input like this x right here, well, it's got 1, 2 outputs. So right there, it's not a function. Again, the vertical line test tests it. But the definition is for any input, you only get one output. Here, any input I have has a single output. So 5 is going to be the only one that is a function in this case. All right. I don't think I have anything after that. No. Hope that helps. If you have any more questions, just let me know. Thanks.